Welcome to physics class in Teacher Black Adam. We have forces acting on a moving object in equilibrium. So we need to know that what are they, which statement is correct. So the correct one is going to be B. The object is moving at constant velocity. So in equilibrium you can't have force net velocity increasing or decreasing and things like that. So B is our answer. And coming to 2, we have a stone thrown downwards, taking time t to reach the ground. So we have there A and t. So we know that area, since the one has to find the area, we know that the area is length times height in 2 dimensions. So 2 dimensions, length is t, height is acceleration, and yeah, so the units is t seconds, and then acceleration is meter per second squared. So t into t squared is, s into s squared is s. So we have meter per second, that's velocity. So we know that we have velocities there. We have 4 choices for velocity, and then that means the change in position. There's a mistyping. So let's look at velocity increasing, constant, or decreasing. So we know that we have t1 there, our area is small. So if we have t there, t2, you find that our area is bigger. So that means that the area there is increasing. So the change in the velocity of the stone. So the velocity will keep increasing as time increases. So D is our best option. And then coming to 1.3, we have ball horizontal constant. You can pause and read, just have to do it fast to save time. So we have there the mass of the ball remains constant, and so kinetic energy after the collision. So momentum is mass times v, and then kinetic energy is half mv squared. And then we know that looking at our problem, we know that let's look at our problem. Momentum was half, so the mass didn't change. So the only way to get half momentum is if we have half the velocity. So that means the velocity is half, and then simplify it to half momentum. So we're gonna take the kinetic equation. We substitute velocity with half of the speed. So that means that squared. So that means half squared is it's going to be 1/4. Then v squared is v squared. So we rewrite the equation. So after we have made some alterations, we need to rewrite the equation as energy. So that's kinetic energy there, that formula. So that means now we have quarter. We factor out 1/4. Okay, so that's quarter of kinetic energy. So answer is A. So in physical sciences, you always have to calculate first if you have to redefine it. So answer there is A. Alright, now we have 1.4. 1.4 gives us 1.4 gives us a force F, and then moving down inclination, constant acceleration, so correctly completes the following statement, so work done by F and friction. Is it combination, difference, sum, greater or less? So let's draw a free body diagram there. So we have G there, we have normal force, and then we have the force applied. We also have friction, and there's normal cancels that. So we have the horizontal forces, that's Fg parallel and F and friction. So acceleration is constant, so which means that Fg parallel is going minus the two forces force applied and friction is equals to ma, but we know ma is 0, so that means our Fg parallel is going to be force plus friction. So that's it. And looking at our action equal of the sum. So that's our answer A. So A is our best option so far. We move on to 1.5. 1.5, let's read the problem. A ball falls vertically downwards from point A strikes the ground, velocity v, bounces, reaches maximum. Right? So there was an impulse, contact time with the ball. I think that's electrostatic contact, so it leaves the ground, and the magnitude of the velocity. Impact of it is upwards as it strikes. I just keep to doubt that as it strikes now. So that means we have, so we have impulse as it strikes. It's wrong, down, wrong, greater, wrong as well, downwards, yes, greater, no, wrong, up, wrong, less, great. So our option is D. It's downwards and the velocity is less than the original one. So that's our answer. Then going to 1.6, absorption spectrum of elements surrounding a moving stone is observed on the earth. And then what we need to do, we need to drum the current orange beef. So that means it's a red up to violet, red, orange, green, blue, indigo, and violet. And then as we move from R to V, frequency increases from V back to R, and then we have frequency decreasing, and then a wavelength increases. So since we want to target the frequency, so we know that redshift, so usually redshift, is it towards or away, so redshift, actually I think it means away, redshift means away. Redshift should mean away. Well, redshift is away. Okay, so why away? Because it has a increasing wavelength, so wavelength increases as you leave the source. Okay, and then blue shift is towards. So red shift away, and then blue shift towards. And then from there we know that we have away, and then we need to know that, okay, two options, is it increase or decrease? So we know that frequency times wavelength is equals to constant. If you increase frequency, you decrease wavelength, increase frequency, decrease wavelength, increase wavelength, you decrease frequency, so that you get a constant, so that's how it actually works. So that means option is A, away from Earth and decreasing frequency. So as any object that moves away, the frequency decreases, whether sound or light. Two small identical spheres, each with mass m and charge q. So we need to know the value of the distance. So the charges are the same. So we have we need to know the distance between them. So we know that we have our force net, actually force, electrostatic force. We have electrostatic force is equals to constant, and then q1, q2 all over the distance squared. And then we know that q1 is equals to q2. We also know that the force net is the mass of the charge, so that is equals to weight of the charge, which is mg, weight of the charge mg. So mg is equals to k, and then we have two of them, so q times q is q squared over r squared. So we just solve for r, cross multiply there, then that means we have r mg r squared is equals to k q squared, and then divide by mg both sides. So mg cancels out, so we have r squared, we have r squared as kq squared, and then all over mg. And that means that solving for r is plus or minus root of kq squared over mg, and then that is a. Okay, and then our answer is a. Then moving to 1.8, so kilowatt hour, a unit of power, electric current, electric energy, or potential difference. Let's see how we define power in electricity. So power is work done in any way, the rate at which work is done. So cross multiplying that, work is equals to power multiplied by a change in time. So unit of power, that's watts, so we have thousands of them, kilowatt. Time, we have hour. So it's work, so work is unit for energy, joules. So that is energy, so it's electric energy that we're talking about. So that makes sense. When you're buying electricity, you're buying the energy so that you can use it to cook and all that. So your unit when you buy electricity is kilowatt hour. So the other thing that we look at is it option A? Yeah, it's gonna move clockwise. You can pause it and read the question, and then that's the solution. It's gonna be B. And then 1.10, which of the following is true? For electric effect demonstrates the following, so I'll go for B, which is light has wave nature and also it's quantized, which means the photon, it's one unit that's quantized. It doesn't change. So thank you for watching, and it's your tutor Black Adam. If you have any question, please leave below. You can send problems as well. Thank you. Don't forget to follow or subscribe.